In this video, we want to find the curvature of r of t equals 5 cosine of t comma 6 sine of t. Now, we're given r of t. Let's find r prime of t. We're going to take the derivative of 5 cosine of t to get negative 5 sine t, and then the derivative of 6 sine t is 6 cosine of t. Now, the second derivative is going to be negative 5 cosine of t and then negative 6 sine of t. We need these to find the cross product of r prime of t cross r double prime of t. Because it's a two-dimensional vector, we're going to let the third component be 0. And the quick way to find the determinant of this is by picking the last column to be the coefficients. So we're going to have k and then a matrix minus 0 times a matrix, determinant of a matrix, plus 0 times the determinant of another matrix. So the way it works is we're going to hide the first row last column, and so the matrix here is negative 5 sine t, 6 cosine of t, negative 5 cosine of t, and then negative 6 sine of t. The other two matrices, I don't care what they are because I'm going to multiply by 0, and that's just going to cancel. Okay, so now we have to find the determinant of this matrix, which will just be, well, negative 5 times negative 6 is 30. That's sine squared. And here's a negative, so it's minus a negative, which is a positive. 5 times 6 is 30. That's cosine squared. And then sine squared plus cosine squared is 1. Multiply by 30, we get 30k. So this is just going to be a scalar. So this is 30k, technically. All right, and then we need to take the length of r prime of t, which r prime of t was negative 5 sine of t and 6 cosine of t. Square each one of those, add them. We get 25 sine squared plus 36 cosine squared. I'm going to break this up so that it's 25 cosine squared plus 11 cosine squared, because now this is going to equal 25. And so in order to find the curvature, we need the magnitude of r prime of t cross r double prime of t over the norm of r prime of t cubed. Now, r prime of t cross r double prime of t was 30k, and so the length of 30k is just 30. On the bottom, we found the length of r prime of t, so we just have to raise it to the third power. But because it was a square root there, I just factored out the root, so that became 3/2 with the cubed. And so now I have to evaluate this at 2 pi over 3. So cosine of 2 pi over 3 is 1/2. I have to square that to get 1/4. So 1/4 times 11 is 11 over 4. Simplify 25 plus 11 over 4 as 111 over 4. And because this is raised to 3/2 power, I can rewrite it as 111 over 4 times the square root of 111 over 4. Now this 4 is going to go at the top here, so you have 30 times 4. That's going to be 120, but then this 4 right here becomes 1/2. So it's like, it becomes 2 really on the denominator. So it's like 111 to the 1/2 power over 2, and then that 2 goes up here. So it's 4 times 30 times 2. That's going to give us 240. We still have the 11, and we still have the square root. I'm sorry, the 111, and then we have the square root of 111, which that's going to be, well, first 240 over 111 simplifies to 80 over 37. If I multiply top and bottom by the square root of 111, I end up with 80 times the square root of 111 over 4,107. And that is our curvature.